Welcome to a new test and teardown video. This time we're going to look at an electronic load. They call this RE Universal Power Sink. That's a little bit funny because this one is made by Radiometer Electronics. So it is some sort of an electronic device from a well-known company here, but I think there is a chance this one may be an internal test equipment or internal prototype or something like that. As you can see here, we got 4 individual loads or power sinks as they call them, and I think that each of these are completely isolated, so you can parallel or something like that, and each of them got 4 NPN transistors, I would assume. And they're of course connected via cables like that. We also got 2 more on the other side. And look at that heatsink. That is some heatsink, and it is of course only working when the fan is running. But the power cable to the fan is a completely individual cable like that. So the fan runs on mains voltage and the rest runs on nothing. It is obviously powered by the DC rail you want to power sync. And as far as I can see, we got an amp meter. It is in 20 amp mode, so 20 amp will be the full range. And then when you hold this down, you have 5 amp range, but it can't stay in 5 amp range. Then you have a switch here with 12 pre-programmed currents, and then you have a potentiometer, and all the potentiometers, they're completely stuck. I was able to move this a little bit by really brute force it, but yeah, see, I think there's something that needs a little bit attention. And here's the back side. You can definitely see the heat sinks. They have been in use before. It looks like it's already pre-drilled for TO3 transistors, but they mounted some smaller transistors instead. Or this is just a lower number of them, right? So you can have, you can have 5 transistors TO3 size, but they are only using 4 of them. Oh, there's a little, I think this means bottom. So that's all there is to it. And then you have an official label. This is Radiometer Electronics logo. And this is Department 10. And so there is an official number, 3303. So if anybody knows that number and can tell me exactly what it is, it would be nice of you. I am ready with the first test. Let's provide 30 volts and 3 amp available on those 2 bananas. First, I want to try something funny. See? Nothing happens if I connect it to any of the other inputs. So that means this is the only one where it's going to have an effect. And here is a thermal camera. You can only see something that is a little bit reflecting. So let's try and power this up. So that is 30 volts, 2.4 amps, 72 watts. And as you can see here, all the bottom transistors, they are heating up. And they're all heating up equally. So that means there will be some sort of electronics inside that will current divide things between the 4 transistors. And here's a little funny thing. When I crank up and down the voltage, current also goes up and down. So it's not a current source or a constant current sort of that. This is just a whatever it is loading, it's just loading. So it's not any accurate measurement equipment or anything like that. The amp meter here is not even accurate as well. So this is 5 amp full range. So this should be, oh yeah, what? It is accurate. So half the readout of 5, right? That should be 2.5. I mean, that is more or less what I got. Because I tried the other one and that was off. I think I actually know why. Because there's a loose wire on the back side. So okay, so that is 20 amp full range. So that could be 2.5. I don't know. No, not exactly right. So anyway, yeah, you can hear this changes definitely the behavior, but this is the variable. Okay, that seems to be. I am using all my finger power here to fine tune this variable one. As you can see here, it is definitely having some sort of an effect. I think we should try and open this. It's probably just those 4 screws, and then we can have a little look inside. So this is what it consists of inside. I gave it some contact 61, all the potentiometers, and look at that. Super easy to turn now, all of them. Easy. Yes, it is of course 4 individual loads. And the fun thing is that, exactly like I said, I did imagine individual local feedback resistors. So that's definitely emitter resistors in this transistor drive. And what you do with the resistors here and the potentiometer, that is just to set some bias from the incoming voltage. Using those transistors, probably the first one here is a pre-driver and the rest they are just in parallel with the 4 transistors. And here's the funny thing, we got an optocoupler, and the optocoupler is connected to each of the B and C inputs. So what I think is, this is a disable. So a disabled pulse can come here and they will turn on the optocoupler, and the optocoupler will turn off the drive. And that means you can modulate or stimulate each of these 4 individual loads to do 4 different currents or powers or whatever settings you have already pre-programmed them to do. And this way you can do a sequence of whatever it is you can imagine, right? If you have a constant voltage from something, yes, you could pre-program this to do 4 different currents or something like that, right? I mean, this heatsink is capable of doing thousands of watts. Really, it is all about how much airflow you have and what kind of temperature rise can you accept. But we got 4 big transistors capable of handling about 100 watts each, 100 or 150 watts each, and you can multiply this by all of these. This is truly a really powerful DC load. Oh, there's one last thing I want to show you. If you note this a little bit careful, can you see? All those transistors, they're all PNP. I think that is a little bit untraditional. So I didn't really find anything really obvious to date this, but I think it should be around the start of the 80s. That is at least what I guess with this, with the single layer PCB, the way that the transistors and the way that everything here is done. And also because I know a little bit about Radiometer and all that kind of stuff. So yes, I think this is internal test system from the 80s or something like that. And if you know more, please feel free to comment. Thank you very much for watching, and bye bye.